Hello students. Previous lecture we had discussed program counter and stack pointer and also the block diagram of generic microprocessor. Today we will start with 8085 microprocessor. The 8085 microprocessor is an NMOS chip. NMOS is a type of transistor. MOSFET is a type of transistor. This MOSFET is divided into PMOS and NMOS. So NMOS is a type of MOSFET. MOSFET is nothing but a transistor. So it's an NMOS chip with 50 pin package. In 11th standard we had done practicals based on IC 7400, NAND gate, OR gate. So they were nothing but IC. Likewise 8085 comes in the form of IC. It has got 40 pins, 20 pins on the left side and 20 pins on the right side. So 8085 is an NMOS chip with 40 pin package, and 8085 is 8-bit microprocessor. That means at a time it can process 8-bit of data. We are learning 80. Why we are learning 8085? Not why we are not learning the other processors, because 8085 is ideal processor which helps in studying the advanced processors. So it is ideal processor to study because its basic architecture is used in more advanced microprocessors. So the Intel's microprocessor 8085 was manufactured by Intel, has selected to understand the hardware of the common microprocessor and to illustrate assembly language program. I told you what is assembly language program. Assembly language program is a machine code which is directly understood by the machine. And high level programming languages, example of high level programming language is C++, which is human understandable format. The compiler compiles it and converts it into machine code, and that code is understood by the machine. But assembly language program is machine language. So we are going to learn assembly language program of 8085. As I had told you before also, the designer of the processor designs these instructions for the specific processor. Those instructions come along with data sheet. I told you what is data sheet. Data sheet which gives the information about the processors. This is a simple basic diagram of microprocessor 8085. It has got crystal X1, X2. These are the pins. As I had told you, it has got 40 pins, 20 pins on left side and 20 pins on right side. Of course, it requires power supply, ground. Crystal X1, X2 is for clock. Processor has its own clock, crystal clock. X1, X2. Address bus processor has. There are three types of buses: data bus, address bus and control bus. This is address bus. Address bus is of 16-bit and it is unidirectional. Can you see there is only one arrow? It is from 8 to 15. 8 to 15. What about 0 to 7? Because there are total 16. There is one more bus which is data bus. Data bus is of 8 bits, so it is from D0 to D7. The remaining address bits, that is from 0 to 7, is used along with the data bus. This data bus is used to carry data, address also and data also. There is this one single bus is used to carry data also and address also. 8-bit data is used. 8-bit bus is used to carry address also and data also. 8-bit address, 8-bit data, and the remaining 8-bit address is carried by the address lines A8 to 815. Why it is two arrows? Because a data bus is bidirectional. Then there is control bus. Control bus is used to carry control signals. It is also bidirectional. This is serial data input output. If the processor is receiving data serially, bit by bit, so it receives through this pin, serial data input. If microprocessor sends data, serial data bit by bit as output, then serial output. This control bus does not have signals related to input output / memory. This we will be learning in detail. The purpose of we have dedicated topic on input output / memory. Excluding this control bus is excluding IO / M bar, and there is dedicated pin for input output / M bar. M bar means memory. Features of 8085. What are the features of 8085? 8085 is 8-bit microprocessor. Why 8-bit? Because at a time it can process up to 8-bit of data. It has got 8-bit data bus width. At a time it can carry 8-bit of data. 8 bits means 1 byte. 8085 chip is available in a 40-pin plastic ceramic package, dual inline package. That it is talking about IC. The address bus is 16-bit. That of course address bus, as we know, address bus is of 16-bit. It means again the width of the address bus determines how much memory it can address. For example, this 8085 has 16-bit address bus. That means it can address up to 2 raised to 16. 2 raised to 16 will give 64 kilobytes KB. So 16-bit address bus can address up to 64 kilobytes of memory. Okay. Figure 1. This figure 1.3 and figure 1.4, the address bus is divided into two groups. See, in figure 1.3, address bus is divided into two groups, AD0 to AD7 and then A8 to A15. Even if you see in figure 1.4, this is figure 1.4, AD0 to AD7, A8 to A15. So, address bus is divided into two groups. First, previous video we had discussed lower address byte and upper address byte. What is lower address and upper address? I will tell you what is lower address and upper address. I'll open the same PPT through which I had explained program counter and stack pointer. See, this instruction is stored at location 0053. This address is of how many bits? 16-bit. Why 16-bit? Because this is hexadecimal value, and in hexadecimal, one digit represents 4-bit. For example, this is 0053. For example, this is 0053. This one digit of hexadecimal represents 4 bits. 8, 4, 2, 1. That means 0, 0, 1, 1. That means 2 plus 1 is 3. Again same thing, 8, 4, 2, 1. 8, 4, 2, 1. This means 0, 1, 0, 1 means 4 plus 1 is 5. So in hexadecimal, this H represents hexadecimal. In hexadecimal, one digit represents 4 bits. So this bit is higher order byte, or we can say most significant bits, and this bit is known as lower order byte. That lower order byte, or you can say least significant bits. Okay, if I will convert these also in 8421 format, 8421, which is 0 0 0 0, and similarly goes with this 8 4 2 1, which is 0 0 0 0. So these two are called least significant bit, and these two are called, sorry, I'm so sorry, these two are called most significant bits, and these two are called least significant bits. So the least significant bits of address, because address bus is of 16 bit, the least significant bits of address are transmitted on the same 8 lines of data bus. The least significant bits, these least significant bits are transmitted over the data bus, which carries data. Data bus is of 8 bits. The least significant bits of address are transmitted on the same 8 lines of the data bus. This bus is known as multiplexed bus. Multiplexed means with one single bus we are transferring two kinds of information. One is address, another one is data. The advantage of multiplex bus is number of pins is being minimized, is being reduced. Instead of having 16 pins for address, 16 pins for address bus, 8 pins for data bus, we have reduced. So total will be 16 plus 8 is how much? 24. But if I will use those 8 bit of data bus for address transmission, for 8 bit address transmission, then it will reduce to 16. Instead of 24, I'll have 16 pins for address bus and data bus altogether. Then most significant bits of address are transmitted on address bus from A8 to A15. Since microprocessor 80, of course, if the address bus is of 16 bit, so it can address up to 64 kilobytes of memory. Each memory location is of 1 byte, because at a time it can address up to, for example, I'll take the same example. At this memory location, I can store only 8 bit of data, because microprocessor 8085 is of 8 bit. Okay, this a particular address location can store up to 8 bit of data only, because at a time the processor can process up to 8 bits. 8 bits means 1 byte. That's why it's written each memory location is of 1 byte, that is 8 bit wide. Now, this we were talking about the memory available in 8085. External memories can also be connected to 8085, and external input output device can also be connected to microprocessor. For example, keyboard, printer. So these external memory are addressed by using the system IO mapped IO system. This I was talking about IO input output slash memory. This is somewhat related to this system. IO mapped IO system. This is completely whole different topic. Okay. Now we will start with functional pin diagram of 8085. we will see the function of each pin of 8085. There are total of 40 pins, 20 on one side and 20 on the other side, out of which these 8 pins are for multiplex address and data bus. AD0 to AD7 from 12 to 19. You have to learn it in sequence, okay? First pin means X1 pin. Second pin means X2 pin. You cannot write that first pin is AD0 pin. No. AD0 pin is 12th pin. Okay? AD0 to AD7. Then address bus A8 to A15. This is from pin 21 to 28, 8-bit address bus. This is power supply, 5-volt power supply, and this is ground. What is pin? The pins carry electrical signals in and out of the chip to allow it to function in a system. So these pins carry signals in the microprocessor and carry signal out of the microprocessors. And each pin has its dedicated function for it, specific function for it. And these functions come along with the chip in a datasheet. The functions of each pin is described in a datasheet of that particular chip. So this we will continue in the next lecture. For today we will stop here. Thank you.